want to see what that looks like.
Growing up, Star Wars was my favorite tale. The characters, the story, the technology was all so amazing, yet somehow seemed possible to achieve. One day at least. As a kid, my brother and I used to always play as heroes and villains from Star Wars, but the toys back in those days made us leave pretty much everything up to our imagination. If you wanted a blaster, the best you could do is a piece of plastic that made a sound effect when you pulled the trigger. I'm not a kid anymore, so my imagination is not so spectacular. I'm gonna have to start building things in real life to get the same effect. So I bought this 3D printer. While I was making random junk with it, I happened to print out Boba Fett's van brace, and I thought, whoa. If I was a kid, I would have loved this thing. Actually, the only thing that could make it better is if it shot Nerf darts. So, if you want the job done right, you gotta do it yourself. The problem is, I don't know how to do this stuff. So it's time to learn how to use CAD, 3D printing, and electronics to get this Nerf blaster done. We've got quite a trip ahead of us. So first off, let's take a look at the source material. Basically, a rectangular box attached to some armor that goes around the wrist. Now, we've got to choose how to launch the Nerf darts out. We've basically got two options. One, using a plunger system with a spring, or two, using flywheels with electric motors. The plunger isn't gonna work because we have to orient it in such a way that it would mean we have to use a hopper, making the blaster gravity dependent. With the flywheels, we can shoot our blaster at any orientation because the mechanism is on the same level as the magazine. I think we'll go with the flywheels this time. We'll be using some of these Kraken motors from Out of Darts. Since we're going with flywheels, we need something that's gonna stop the foam balls from feeding when the motors are speeding up or slowing down. I figure we could just use a little servo like a gate. Whenever we're not holding the fire button down, the gate's up. Otherwise, it's down. Too bad the servos take 5 volts while the motors take 12. We're gonna have to use a 3S LiPo battery and regulate the voltage for the servo with a buck converter. We'll throw in a Arduino microcontroller to detect when the button to fire is pressed, control the servo, and also activate a relay that lets the full 12 volts flow to the motors. I actually broke 2 relays when the ground wire slipped out. Awesome! The prototype on the breadboard works. Let's solder it into the proto board. Is the microcontroller on the right way? No. Lesson learned. Never solder the microcontroller directly to the board. Use sockets instead. Okay, after that little detour, everything's hooked up and ready to go. Time to model this blaster. I started by designing the housing for the electronics. I figured we could kind of split the source material down the middle. The bottom half holds the electronics while the top half holds the darts and the flywheels. The electronics housing has little motor-sized holes where we can slide in the motors, then enough space for the rest of the electronics. I figured I should make the blaster detachable from the wrist armor, and I could have them connect using a Picatinny rail. So I made a little egress into the electrical housing where we could screw the rail into later. The electrical housing went pretty smoothly. My noob level expertise started showing afterwards though. I was designing parts thinking the 3D printer would solve all my problems, not really concerned about the practicality of the part. Big mistake. This led to printing error after printing error, and when it did work, I'd spend an unbelievable amount of time taking apart supports that left the part rough and inaccurate. So I finally started to separate the complex parts into more manageable parts that the printer could handle with ease. After that, the housing for the flywheels and the electrical housing cover went great. The next challenge was the magazine. It turns out, foam balls are really uncontrollable. They've got a lot of degrees of freedom, so if you aren't super considerate of the constraints on your design, they're gonna spread around, rub against each other, and in general just get stuck in your design and cause a lot of problems. Silly me, thinking a rectangular spring from one of the Talon mags I had laying around would work. I spent days redesigning this magazine, trying to get all the balls to easily flow through the magazine, all while fighting with the fact that the spring couldn't be made any less wide. The magazine is a big problem to solve. After all, how do I get the balls into the flywheels without it? My first solution was to just make a big box that had a spring attached to a feeder on one end. Turned out, this didn't work at all. The balls weren't exiting the magazine whatsoever. At first, I believed the problem was the design of the exit. I thought since it was flat, that the extra balls were being prevented from moving and adding friction to the whole system. So I added a taper all the way down the magazine. This didn't work either. It became apparent that having a magazine wide enough for multiple balls to line up next to each other was the actual problem. If the balls were harder, this wouldn't even be a problem, but since they're too squishy, they're able to squeeze next to each other and jam the magazine. And thus, I had to make the magazine narrower. In fact, I had to make the magazine less than 1.5 balls thick. That way, the balls would never be able to get next to each other and jam the gun. This was a step in the right direction, but it only worked half the time. The other half they were still getting jammed at the feeder. So, to fix this, I moved on from the naive feeder that we had before and made a feeder that had a protrusion that offsets the balls on one side. That way, it starts the stacking pattern correctly and prevents jamming at the feeder. In reality, we can look at how Nerf solves this problem. All their blasters that use rival balls either use a hopper or have the balls aligned in a single file to prevent this problem from ever happening. The magazine has these two clips on the side that slide into the two holders on the flywheel housing. And on the bottom of the magazine, there's a magnet that aligns with the other magnet super glued to the back of the electrical housing. Everything all fits together. All that's left is the wrist armor. I started out by basically measuring the circumference of my wrist and the top of my forearm, and I printed out a big plastic tube that tapered down the length. It left a lot to be desired. So I went back, and the second iteration was shortened, had a little bit of a cool lip on the top, and had a Picatinny railing on the top and side with a hole for a bar magnet in each. This one worked, but it wasn't exactly form-fitting or functional, but was definitely a step in the right direction. The third iteration was a clamshell design. Basically, I turned the wrist hole into an oval so it hugged the arm better. Cut the design in half and added some hinges on one side and an area to insert some clasps on the other. I also put holes on both sides where magnets could be inserted. Printed this one out, used some 2mm rod in the hinges and 2mm rod for the clasps, super glued in the magnets, and boom, wrist armor is done. Time to attach the rail to the blaster. Look at that, the whole ensemble working together in harmony. This thing is really great, especially for my first project. I feel pretty satisfied with how it turned out. However, there's a lot to be desired, especially with how hard it shoots. I wish it shot harder. I think a lot of that has to do with the fact that I chose the flywheel design, since the flywheels are actually only touching the ball at one place. There's not a lot of time to build up speed. Next time I think we'll definitely go for a plunger. If anyone has any suggestions how to make this thing better, comment it down below. Also, like and subscribe, and let me know if there's anything cool you want to see tried. All in all, this project was really fun and a great way to get started on this journey. I can't wait to make some more projects and see what you guys think.
It worked. I crossed my legs.